Good morning, everybody. Thank you for your participation. Yeah, we are excited. And we can start, I think, as we planned to finish in 60 minutes. Today's seminar, we are going to talk about novel solutions on twin screw compounding and rotational, oscillatory, and extruder capillary rheology. Actually, we planned it as 3 speakers, but we have a little surprise today. Very important name from the industry just joining us. Thank you for his contribution. I would like to introduce you Ahmet Meriç from PAGEV, Turkish Plastic Industry Foundation Vice President. Good morning, günaydın.
Good morning. Good morning everybody. Günaydın. Herkese iyi günler diliyorum.
Her şeyden önce çok teşekkür ediyoruz. Bizim için çok büyük bir onur. Gerçekten son dakika bize katılmaya karar verdiniz. Ve sizden özellikle PAGEV'in çalışmaları ile ilgili bilgiler almak istiyoruz. Akabinde eğer bizimle kalırsanız sorular varsa cevaplamanızı rica edeceğiz. Çok teşekkürler.
Kesinlikle. Öncelikle bizim için bir onur programımıza katılıyor olmak. Ben öncelikle Untitled HAAKE firmalarının beraber düzenlemiş olduğu bu programa katılmış olmaktan memnuniyet duyduğumu bildirmek isterim. PAGEV ve PAGEV Yönetim Kurulu adına sizlere de hoş geldiniz demek isterim. Sunumum çok uzun olmayacak. Melek Hanım sağ olsun bizi davet etti ve kıramayacağımız bir insan. Çok kısaca ben vakfımızdan ve neler yaptığından bahsetmek istiyorum. Uygunsa sunumumla başlayabilirim. Evet. Evet, PAGEV, Türkiye plastik sektörünün birleştirici gücü sloganımız. Müsaadenizle şunu izlemek istiyorum. Önce kısaca bir Türkiye'deki plastik sektöründen bahsetmek istiyorum. Belki şu an dinleyiciler arasında plastik sektörü çoğunlukludur diye tahmin ediyorum. Plastik sektörü yanında diğer endüstriler de olabilir. Biz tabii ki PAGEV olarak plastik araştırma, geliştirme ve eğitim vakfı olarak Türkiye'deki plastik sektörünü temsil ediyoruz. Türkiye plastik sektörü aslında genelde dünyadan başlayacak olursak 1950 yılında dünyada 1,5 milyon ton plastik üretimi varken artık günümüzde her sene yaklaşık %8 artarak 350 milyon tona kadar çıktı. Dolayısıyla plastik endüstrisi dünyada önemli bir endüstri haline geldi. Türkiye burada nerede? Türkiye plastik üretimi noktasında dünyada 6. sırada. Yani yaklaşık 9 milyon ton plastik işliyor ve dünyadaki 6. büyük plastik işleyici ülke. Plastik sektörü Türkiye'de 6500 civarında firmadan müteşekkil. Yaklaşık 35 milyar dolarlık bir üretim değeri var bu 6500 firmanın. 300 bin kişiye yakın istihdamı var plastik endüstrisinin. Türkiye ekonomisine 13,7 milyar dolarlık bir katma değer sağlıyor bu 6500 firmayla. Ayrıca ciddi miktarda ihracatı olan bir sektörüz. Direkt plastik ve dolaylı olarak yapılan ihracatlarla, çünkü biliyorsunuz plastik bir malzeme olarak birçok üretilen eşyanın üzerinde de var. Mesela otomotiv, beyaz eşya gibi. Toplamda 13 milyar dolarlık direkt ve indirekt ihracata sahip plastik endüstrisi. Türkiye'nin gayri safi milli hasılasında da %4,4 kadar bir paya sahip. Diğer taraftan diğer endüstrilerle kıyas edildiğinde de 10. büyük ihracatçı sektör Türkiye'de plastik endüstrisi. Kimya sektörünün altında genelde plastik endüstrisi ele alınıyor ve kimya sektörünün içerisinde de %34 payla kimyanın en büyük ihracatçısı konumunda plastik endüstrisi. Bahsettik rakamlardan ve bu rakamları oluşturan firmaların %99'u Hatta çoğu, %99'u KOBİ ölçeğindeki firmalar. Dolayısıyla biz PAGE olarak bu firmaları birleştirici bir rol oynuyoruz. Aynı çatı altında toplanıp sorunları çözmesine fayda sağlayacak bir yapıyız. PAGE'nin kuruluşu 1989, yaklaşık 1150 ilişkili firması var. 800'e yakın mütevellisi var, yani direkt üyesi var. 300 bin çalışanı ve 11 bin firmayı totalde sektör olarak temsil eden bir kurum. Plastik sektörü dediğimiz zaman tabii aslında çok farklı alanlarda var. Az önce söylediğimiz gibi ambalaj, inşaat, otomotiv, beyaz eşya, elektrik, oyuncak, medikal gibi birçok alanda plastik kullanılıyor. Dolayısıyla bizim üyelerimiz arasında da bu alanlarda faaliyet gösteren firmalar söz konusu. PAGEV aynı zamanda yurt dışında da sektörün temsilini yapmakta. Dolayısıyla yurt dışında plastik sektörüyle alakalı olan Plastics Europe, UPC, Asokomoplast gibi, Sayfet gibi kurumların da aynı zamanda üyesi. Tabii PAGEV neden kuruldu? Ondan bahsetmek lazım. PAGEV'in temel kuruluş maksadı adından da anlaşılacağı üzere aslında eğitim. Sektörün eğitim eksiğini gidermek maksadıyla, eğitimli eleman eksiğini gidermek maksadıyla kurulmuş. Artı sektörün daha verimli Ar-Ge yapmasını sağlamak temel hedeflerinden bir tanesi. Bu doğrultuda da PAGEV faaliyetlerine başladığından bu yana 2 tane meslek lisesi inşa etmiş. Bir tanesi Anadolu yakasında, İstanbul'da, bir tanesi de Avrupa yakasında, Halkalı'da. Bu toplamda bu 2 meslek lisesinin 2000 öğrenci kapasitesi var ve sektöre ara eleman yetiştirme amacı hedefi gidiyor. Tabii PAGE bu liseleri inşa ettikten sonra Milli Eğitim Bakanlığı'na teslim etti ve devretti bir protokol çerçevesinde. Fakat yine okullarla olan iletişimi devam ediyor ve okulların çeşitli ihtiyaçlarını karşılamaya ve okullardaki öğrencilerin eğitimine katkı sunmaya çalışıyor. Burada hemen kısaca bu faaliyetlerden çok hızlıca bahsetmek istiyorum. Öğrenci sanayici buluşmaları düzenliyoruz. Öğrencilerimizi çeşitli fuarlara götürüyoruz. Bunun yanında farklı faaliyetler, öğrencilerin içinde bulunduğu farklı faaliyetleri onlara da katmayı ve sektörle tanıştırmayı hedefliyoruz. Yaptığımız diğer organizasyonlara da onları katmaya gayret ediyoruz. Burada bir takım okullarımızla ilgili görüntüler var. Hızlıca geçiyorum. Sizin de vaktinizi çok almamak üzere. Tabii okullarımızı desteklemek, mesleklerimizi desteklemenin yanında çeşitli üniversitelerin plastikle ilgili bölümlerini de aynı şekilde desteklemeye gayret ediyoruz. İstanbul Üniversitesi'nde burada yapılan bir faaliyeti görebilirsiniz. Yine aynı şekilde öğrencilerimizi K Fuarı'na sponsor olarak götürdüğümüz bir organizasyondan görüntüler var. Bunun dışında farklı eğitim faaliyetlerimiz de tabii ki var. Firmaların eğitimlerini desteklemeye çalışıyoruz. PAGEV Akademi adı altında düzenlediğimiz çeşitli eğitimleri firmalarımızı katmaya gayret ediyoruz. Aynı zamanda sektörün algısıyla ilgili de çalışmalar yapıyoruz. Burada PR şirketimizde yaptığımız çalışmalar var. Yine üniversitelerde, farklı üniversitelerde, İstanbul Teknik Üniversitesi'nde veya 18 Mart Üniversitesi'nde veya herhangi başka bir üniversitede yaptığımız çalışmalarla ilgili görseller var. Bunun dışında bizim için en önemli konulardan bir tanesi yine sektörün Ar-Ge faaliyetleri. Bu noktada da şu zamana kadar yapılmış çalışmaların yanında bundan sonrası için çok önemli bir projemiz var. Burada belki yine Anamet ve ilintili firmalarına çok iş düşecek, öyle düşünüyorum. Çünkü biz çeşitli araştırmalar sonunda Türkiye'de de plastik sektörünün firmalarının Ar-Ge yapabileceği, sektör firmalarının Ar-Ge yapabileceği, paylaşımlı Ar-Ge modeliyle Ar-Ge yapabileceği bir mükemmeliyet merkezi inşa etme ve oluşturma noktasında çalışmalara başladık. Bununla ilgili protokoller yapıldı. Devlet desteği de bu anlamda alındı. Sanayi Bakanlığı ile yapılan protokol çerçevesinde hemen Halkalı'daki meslek lisemizin yanı başında, oradaki arazinin içinde bir mükemmeliyet merkezi, yani bütünleşik Ar-Ge yapılacak bir merkez inşa etme projemiz var. bizi çok heyecanlandıran proje. Çünkü sektörde malumunuz plastik sektörü çoğu hobilerden oluşmakta olan bir sektör. Aynı zamanda ihracatımız çok fazlaca var ama nitelikli ihracat değil, ürünlerimiz nitelikli ürün değil. Buna çok katkı sunacağını düşündüğümüz bir merkez olacak. Yani Ar-Ge derken üretimi de destekleyen bir model olacak. Bir ürünü Ar-Ge'sinden başlayarak, yani en temel araştırmalarından başlayarak prototip ürün haline getirmeye yetecek düzenli bir araştırma merkezi, mükemmeliyet merkezi çerçevesi çiziliyor projemizde. Bunun ilk adımları önümüzdeki günlerde bir temel atma töreni gerçekleşti. Fakat inşasına da önümüzdeki günlerde başlanacak ve birinci etap devam edecek olan çalışma birinci etabı için önümüzdeki günlerde start veriyor olacağız. Mükemmeliyet Merkezi bizi heyecanlandıran bir proje. Bunun dışında PAGE Akademi'den bahsetmiştim. Sektörün eğitim ihtiyaçlarını gerek düzenli eğitimlerle, sektörden firmaların katılımıyla, gerek de firmaların talepleri ve yerinde eğitimlerle devam ediyoruz. Konusunda uzman eğitimcilerimiz gerek söylediğim gibi firmalara giderek yerinde eğitim verebiliyor firmaların talepleriyle veya bunun dışında zaten düzenli olarak yaptığımız eğitimleri devam ettiriyoruz. Burada bazı görüntüler görebilirsiniz yaptığımız eğitimlerden. Farklı organizasyonlara katkımız oluyor. Yine Polymer Processing Society'nin önemli bir organizasyonuna PAGE olarak katkıda bulunuyoruz. Diğer bir faaliyet PAGE'nin yürüttüğü mesleki eğitim yeterlilik belgesi. Yine PAGE, MYK'nın yetkilendirilmiş kuruluşu, plastik alanındaki mesleki eğitim yeterlilik belgesi PAGE tarafından firmalara ve firma çalışanlarına verilebiliyor. Burada gördüğünüz hangi alanlarda mesleki eğitim yeterlilik belgesi verebildiği PAGE'nin liste halinde görebilirsiniz. Bu bilgiler yine PAGE'nin web sayfasından çok rahatça ulaşılabilir. Nitelikli eleman yetiştirmek yine konusu. Bunun dışında PAGE'nin araştırma ve raporlama faaliyetleri var çokça. Ve bunlar tamamen sektöre açık. PAGE'nin web sayfasında tamamını bulabiliyorsunuz. Sektörel bilgiler, sektörel trendler, sektörle ilgili raporlama çalışmalarımız herkese açık. PAGE'nin web sayfasından ulaşılabilir durumda. Türkçe ve İngilizce olarak, bazıları yabancı dilde İngilizce olarak da bulunuyor. Burada daha evvel yapılmış olan raporlamaların bazılarını görebilirsiniz. Sayı daha da fazla. Yayın faaliyetleri var. Hızla geçmeye çalışıyorum. PAGE'nin 2 ayda bir yayınladığı sektör dergisi, PAGE Plastik dergisi. Çok uzun zamandır. Hemen hemen 10.000 tirajı olan bir dergi. Ve bunun yanında da PAGE Fuar Gazetesi, fuar dönemlerinde yayınladığımız bir gazete. Bunun dışında yine sektörel yayınlarımızda sektörle ilgili kitapların yayınlanması PAGE tarafından yapılıyor. Ayrıca yılda 2 defa düzenlediğimiz kongrelerimiz var, uluslararası kongreler. Artık 13. 14. senelerine ulaşmış olan kongreler. Son yapılan 4 kongrenin ana teması başlıkları slide sayfasında görülebilir. Gerçekten ciddi katılım alan, sektörün bir buluşma noktası haline gelmiş olan kongrelerimiz. Bu sene ve geçen sene maalesef tabii ki pandemiden dolayı kongremizi gerçekleştiremedik ama yeni kongremizin tekrar fiziksel olarak yapılacağı bir ortamda, yani artık tabii bu online sunumlara çok alıştık ama fiziksel olarak yapılacağı ortamda gerçekleşmesini heyecanla bekliyoruz. Önümüzdeki sene tahmin ediyorum tekrar kongrelerimiz devam edecek. Burada yaptığımız kongrelerle ilgili birkaç görüntümüz var. Arkasından tabii sektörü temsil ettiğimiz için sektörle zaman zaman buluştuğumuz çalıştaylar da düzenliyoruz. Türkiye'de il sektörün yoğunlaştığı illerde çalışmalarımız devam ediyor. Sektörün sorunlarını dinliyoruz. Onlara çözüm üretmek adına bir takım aksiyonlar almaya gayret ediyoruz. Evet, bu kısımları hızlı geçmeye çalışıyorum. Tabii bizim için çok önemli bir şey yine Plastik Avrasya Fuarı. Uzun zamandır TÜYAP'la beraber düzenliyor olduğumuz fuar. Bu sene inşallah düzenlenebilirse 36. defa düzenleniyor olacak. Ve dünyanın her yıl düzenlenen en büyük ikinci fuar diyebiliriz China Class'tan sonra. Bizim için çok önemli. Sektörün uluslararası bir buluşma noktası oluyor fuarımız. Bizim için heyecan verici bir şey. Her geçen sene büyüdüğünü görmek. Evet, yine fuar içerisinde birçok organizasyonumuz, faaliyetimiz oluyor. Bunlarla ilgili görüntüleri görebilirsiniz. Yurt dışı fuarlara da delegasyon olarak plastik sektörünü PAGE organizasyonuyla götürmeye gayret ediyoruz. Burada onunla ilgili bazı görseller var. Tabii PAGE'nin önemli bir misyonu da sektör temsili. Dolayısıyla bakanlıklar nezdinde sektörün problemlerini çok yakından takip ediyoruz. Hızla bu slaytları da geçiyorum. Çeşitli bakanlıklarla artı sektör sorunlarını medyada gündeme getirip bunlarla ilgili bakanlıklarla çözüm arayışı içerisinde oluyoruz. Bu faaliyetlerimiz hızlıca geçiyorum. Bazı örneklerini görüyorsunuz slaytlarımızda. Sektör sorunlarıyla ilgili çalışmalarımızın. Evet. Tabii sadece yurt içinde değil, yurt dışında da Türkiye plastik sektörü için bir takım çalışmalarda bulunuyoruz. Diğer yurt dışı örgütlerin, uluslararası örgütlerin toplantılarına ve onlarla yürüttüğümüz bazı çalışmalara iştirak ediyoruz. Evet, tabii önemli bir konuda plastik sektörünün gündeminde olan sektör algısı konusu. Plastik sektörü tabii maalesef çok hoşumuza gitmese de algısı biraz kötü sektörün. Bunu düzeltici yönde, geri dönüşümü destekleyici yönde çalışmalarımız var. Medyada rastladığınızı tahmin ediyorum, düşünüyorum. Yakın zamanda tekrar bir bununla ilgili çalışmamız, projemiz medyada yayında olacak. PAGEV'in ayrıca geri dönüşümle ilgili çalışmaları var. PAKÇEV bir iktisadi işletmemiz. PAKÇEV çatısı altında devam eden. Bunun detaylarına girmeyeceğim. Kendi başına ayrı bir faaliyet. Biz sorumluluk alıyoruz. Sektör olarak sadece hani doğayı kirleten her endüstrinin çıktıları var. Plastik sektöründe pek tabii ki var. Biz burada sorumluluk alarak geri dönüşümlü, sektörün atıklarının geri dönüşümünü desteklemeye gayret ediyoruz. Evet, sunumum bu kadar. Dinlediğiniz için çok teşekkür ederim. Dinleyiciler arasında eminim PAGEV'i bilenler vardır veya bilmeyenler de olabilir. Plastik sektörüyle alakalı herhangi bir konuda PAGEV'i destekleyici kuruluş olarak görebilirsiniz. PAGEV'e ulaştığınız zaman profesyonel arkadaşlarımız her konuda size destek verebilir. Sizi de PAGEV çatısı altında görmekten mutluluk duyarız eğer PAGEV üyesi değilseniz hala. Sizleri de üye olmaya davet ediyoruz. Bundan sonraki kısım esas günün konusu. Ben teşekkür ediyorum bu programa bizi de dahil ettiği için Anamet ve HAAKE'ye. Umarım herkesin çokça istifade edeceği güzel bir sunum olacak. Paylaşımlı, bol paylaşımlı bir sunum olacak. Hepinize teşekkür ediyorum. İyi günler diliyorum. Çok sağ olun.
Biz çok teşekkür ederiz Ahmet Bey. Gerçekten çok güzel bir sunumdu ve dolu dolu anlattınız bize faaliyetlerinizi. Hakikaten birleştirici güç. Bugün de zaten compounding'den bahsedeceğiz, birleştirmekten. Evet. Yeni bir şeyler üretmekten. Biz hem Anamet hem de Thermo grubu adına söyleyebilirim ki çok heyecan duyuyoruz. Özellikle eğitim ve bu trend konuları konuşma konusunda. O yüzden böyle bir semineri de düzenlemek istedik bugün. Mümkün olduğunca dünya ile beraber eş zamanlı olarak trendleri izlemek, takip edebilmek, güncel konuları öğrenmek adına beraberce bir seminer düzenledik ama sizin katılımınız çok değerliydi. Çok teşekkürler.
Rica ederim.
İnşallah en kısa zamanda da dediğiniz gibi yüz yüze devam ederiz çünkü hepimiz çok özledik. Ama şimdilik biraz daha küçük sabırla belki aşı takvimine göre yeniden düzenlenecektir fuarlar, kongreler. Hepimiz çok özlüyoruz. Çok teşekkürler katılımınız için.
Teşekkür ederiz. Heyecanlı sunumları bekliyoruz.
Teşekkürler, saygılar bizden de. Çok değerli hocalarımız var bahsettiğiniz gibi. Kalırsanız bizimle belki sonunda soru cevap ya da sohbet şeklinde de devam edebiliriz.
Çok teşekkürler. Burada olacağım.
Sağ olun. Okay, this was really exciting. Thank you for his speech to Mr. Ahmet Meriç. And today's topic is novel solutions for twin screw compounding and rotational oscillatory and extruder capillary rheology. Actually, yeah, can we share our presentation? Thank you, Ansgar. Okay. Okay, so our first speaker is Ansgar Frenda, who is a channel manager at Thermo Scientific company, and he's responsible for Turkey. We know each other for years, maybe more than 15 years. I know he enjoys always to travel to Turkey, to visit Turkey, but right now we just have chance to go online. So thank you for today. And during your presentation, actually, again, we have one exciting event. Annika is here with us. She's connecting from application lab in Karlsruhe. She's application specialist for extrusion. Good morning, Annika. Hello. Yeah, I think she
might still on mute.
Good morning.
Good morning.
Yes, wonderful.
So we are really exciting to have a tour in application lab, and we want to see and hear about the machines with the different scales and possibilities from application side. I'm sure you will give very useful information for us. Thank you. And in the last part, I'm Necla Kılıç Arslan, working in Element Analytic Group company as a sales manager. But for 18 years, I'm dealing with the Thermo Scientific extrusion and rheology part business. So I'm going to talk about the rheology and rheological measurements with compounders and reometers, correlation of the data, and give you a little bit information on our reometer systems and with the combined methods. But before switching to our presentation, I would just ask you to, we will have a short questionnaire. So can you please just answer these short questions, and then we can move to Ansgar's presentation. Thank you. I think we completed because there was, as I cannot vote as a panelist, I think you completed the questionnaires. So thank you. We can continue with Ansgar. You have the word.
Okay, thank you.
Thank you.
I hope you can hear me. And I'd like to thank you first for the friendly introduction from Pagev and from Mr. Mesic. And what we see, what I like to see was this full planar people sitting in a planar room, even how important the plastic society, the plastic processing is, even teaching kids, assumingly in school, with events. And so I think this is a very healthy way of bringing the message to the people that plastic isn't always easy. Plastic is required in industry. Plastic helps us also to tackle the next troubles, what we will see in terms of pollution, in terms of microplastic floating around in the seas. And yes, we are doing also with small things, with our small instruments, we can contribute also in this field to help recycling industry to look at innovative processes. Further down the presentation, we will have an example how to use wood compounds as a fillers for plastic materials to reduce the amount of plastics. Yeah? And so short view on the table of content. I will speed up a little bit. Introduction to compounding extrusion and an overview on the instruments, followed by Annika, who joined Thermo Scientific for about, is it now 4 months?
6 months.
Months? Yeah.
6 months it's now.
6 months is now, and she's quite new, but excellent. She's coming from KIT Institute for Mechanical Engineering in Karlsruhe. So basically the university in Karlsruhe for engineering, and actually a very good place also for us. Not only to look for further employees, we have a couple, but also to co-work and to have access to science and support there. So that will be a small tour through the laboratory. Unfortunately, at this moment, we are not yet too ready to host customers. The first customers have come personally now to the lab. There is still a few restrictions, but it's picking up. It's picking up. We will see more customer visits. Hopefully, we will see also something like conventions in person and not only online in the future. Then I would like to continue with a little bit on screw elements, screw design, application examples, and to highlight one topic which is related to 3D printing, basically infused filament deposition, so plastic filaments, and to use a twin screw extruder to produce those filaments, so tailored filaments. Followed on a large overview from Nejla on rheology, and this particularly rheology with extruders, rheologies with reometre, so rotational and oscillatory measurements, and of course questions. We will have a question session, and I think Yunus or Nejla, you will collect all the questions in the chat box. So don't hesitate to type your question in the chat box, and somehow we will try to answer it during the session or later on. Somehow we will manage. So thank you for that. And let's start. So twin screw or compounding, extrusion. What is extrusion? By, let's say, definition, extrusion is something where we use a force to push material through a small orifice, what we call typically a die, and create something like a noodle. Compounding yet is something to do with mixing. So whenever we look on an extruder, sorry, I should select somewhere the laser pointed. Do we get it? All right. The extruder over here is a big term. There are various things of what is called extruder for making minced meat, for example, to extrude even something like alumina. But we are more talking on polymers today or plastic materials. So the extruder we are talking on, we will see a single screw extruder, and there are twin screw extruder. So the basic difference, twin screw extruders can mix, single screw extruders can't mix. Don't take this too serious because there are always exemptions. Yeah, there are some exotic designs, I would call it, yeah, where the single screw is moving, serving as a twin screw compounder, or not only twin screw with 2 screws, but with much more screws, up to 20 screws in a row. But we would not look at that ones, but we will follow the row twin screw extrusion. Mostly we will talk on a parallel design. For a certain reason, the parallel design is self-wiping, yeah, and is pushing the material from handing over the material from one screw to the other, pushing the material towards the die. So if you have 2 screws, these 2 screws could be either counter-rotating or co-rotating. And in fact, we have twin screws in our product range, parallel and co-rotating. These are the most ones, but also we have a counter-rotating ones and a conical design as well. So there are various arrows here moving from one section to the others, quite a few of designs for extruders and compounders. Okay, next slide. Yes. So where are the extruders used? The main topic, and also from the introduction, we have seen this is widely in the polymer range. But what is also new a little bit to our company, it's the food and also pharmaceutical areas, where nowadays plant-based protein food as the meat analogs are produced by a compounding process. And of course, if we move over as one big group of customers, and especially very strong in Turkey as well, is the academia section, because our extruders usually are lab scale twin screw extruders, so they are kind of small. And if we move to production, usually it's for very novel products, for expensive products, for products which are required to be produced in a very small quantity, or where the available samples is coming in a very small quantity. So you can imagine in academia, this is quite often the case. It's not easy, let's say, to produce the newest materials on a big scale, looking at 10 years back, 15 years back to nanomaterials, to nanocomposites. It was really difficult to source those nanomaterials, and there were very, very few extruders who could compound in a scale for a few grams. So pulling up here a few of the examples, and you see sustainability is at this moment also a very hot topic also for our company. Going further on, looking on the quick view on the portfolio, what we have is a so-called mini family, a mini compounder, mini rheology compounder, benchtop injection molders. So these instruments here are dedicated to very small quantities of sample. We are talking from something 3 to 10 grams. Yeah. So when the sample mass is hardly available, or there is a limitation, let's say, for the product or what is processed in some way, this is a one point. Or it needs to be a fast cleaning, tabletop, little space consuming, a small footprint of an instrument. So there we could use these compounding instruments. The difference to the other systems, what we will show, is basically the conical design, where we have conical screws. One point for conical screws, for example, is saving space in the extruder barrel. And so for these designs, we can save on the material which we require for one test. Going further, torque reometer systems. Torque reometer systems, specifically what we call nowadays, since 20 years over, a polylab system, is a torque reometer, which means it has a base unit connecting with a device for different purposes. So we can connect one device for mixing, connect here a device for extrusion. What you would see is a mixer system, and here a single screw extruder system. Nevertheless, there are also compounding systems. We have one scale bigger. We had defined one system is more or less for customers working in quality control, and the other system is more dedicated as open system, dedicated for R&D. One thing very specific, an online reometer sitting on a huge twin screw extruder in base polymer processing. So measuring also here the rheology. So all this is related to rheology as well. Compounding system, basically twin screw compounders are available in different sizes, going from something like 20 grams, so a little bit bigger compared to the mini family, up to something like 50 kilograms per hour. Now it depends from which perspective you would look at it, whether you work in industry on a compounding line, 50 kilograms per hour, that's lab scale probably for you, or maybe pilot scale. So that is still quite little. If we look on pharma systems, so working also with polymers, with biodegradable polymers, 20 kilograms per hour could be quite a bit. Yeah? And so it always depends how much sample is available, how special your product is. Do you look after very quick sampling? Because if you have a small footprint, easy cleanable system, your production is very fast if it goes to production of the production of results, yeah? Not only production of materials. So here you have the range on the compounding systems. We do have, I mentioned this, for food and pharma dedicated instruments. Actually, the screw itself, or sometimes the motor itself inside, is pretty much the same. What is different is a requirement from our customers in terms of GMP design of IQ, OQ, PQ, as well easy cleanable, completely to be disassembled extruder barrels. Yes, you can see it. Either we can open the extruder barrel completely. Everything is made from the, everything in contact with the material is made of the stainless or pharma grade steels. Also here, various sizes is available, from very small systems dedicated to implant manufacturing, what is called hot melt extrusion, up to a larger scale granulation, continuous granulation of materials. Along with those products also, we have range of downstream equipment as well for the feeding equipment. I will discuss a little bit on feeding for the twin screw compounding, because for twin screw compounding, this is always a major factor, also in terms of the required budget when looking for an investment for the lab. It's not only the extruder, but you always have to consider the feeding system. Why is that? If nothing goes into the extruder, nothing will come out. Extrusion is a continuous process, and so we always have to look in detail to the possible feed solutions. Also here, a selection of feeders. Now I would like to hand over to Annika to show you the laboratory in Karlsruhe, and I hope to welcome the one or other from you soon in our lab when we can be fully opened again. So, let's see. All right, and stopping the sharing over here.
So, thank you, Ansgar.
Have a nice
Welcome.
picture, so it should work.
Great. Welcome, ladies and gentlemen, to our customer center in Karlsruhe. Yeah, as Ansgar said, we're located in Karlsruhe. This is about 130 kilometers south of Frankfurt, so about 1 hour drive here. And yeah, we welcome you here to visit us, or even to send us your samples, and we try to find a solution for extrusion or mixing for your sample. So first, I now move you to our process lab. So our customer center is divided in 3 parts. We have the lab part dealing with the reometers. We have the process part where it's all about extrusion of plastics. And we also have a pharma department. So first we go to the lab for extrusion of plastics, foods, and so on. So here you have a quick view of one half of the lab. And here in my back, you see our machinery park of polylab systems. So here you have several mixers of different sizes. Move you on. Extruders, conical twin screw extruders, parallel twin screw extruders, and single screw extruders with different screw shapes to be inserted. And also a lot of downstream equipment which is located behind these extruders. All these machines can be connected to a drive which is located here. This is the polylab drive unit. But we also have another system, as Ansgar mentioned before. We have parallel twin screw extruders of various sizes. Here you see the biggest one we have in our lab and also in our portfolio, which is a machine that has screws with a diameter of 24 millimeters. And the screws are assembled with single elements. So that allows us to customize any screw for your application and find the best solution for the extrusion. So here we have a lot of space to build up here some extrusion line according to your needs. It's our workbench. Also very important, some space to clean everything afterwards. Cleaning takes quite a while. Unfortunately, today there's nothing going on here. We have no test today, but I would say every second day we have lab trials. So now we move on to our smaller extruders. So next extruder I want to show you is then a twin screw extruder, parallel twin screw extruder with a diameter of the screws of 11 millimeters. So that's much smaller. We also have 16 in between, but unfortunately today I have no machine here to show you in the lab. It's coming back soon. Yeah, all our twin screw extruders have a split barrel design. So you can take off the upper barrel, which is very nice for cleaning. Sometimes can be really important because if you have the extruder blocked, you really like to take it apart and clean it. Otherwise, it takes ages to get it clean again. Here, we also have some feeders here for this smaller extruder. And that's our smallest compounder we have here in the lab, which is the mini lab. This is the conical twin screw extruder Ansgar talked about. Nice thing is also with these two small lab extruders, you can also fill some molds for this mini injection molding machine. So we have different molds. No, it's not taken apart. With different shapes to form specimens from your extruded product. And with these specimens, we can directly go to the other lab and measure the rheology of your compounds. Here we also have a 3D printer for testing the 3D strands. And what I'm missing now here, but usually here is actually now currently in repair, is our scanning electron microscope, which is really useful to analyze the extrudates directly after extrusion. So now I want to move you to another lab. So as I said, after you prepared our extrudates, we can go on to the lab section, which is here. Quick look here. Yes, some working going on. And here now you see our rheology lab where we have several reometers. We have actually 2 rooms with reometers. To investigate on the rheology of the extrudates or even your paste. And last but not least, I want to show you the pharma laboratory. Therefore, I'll move you here. So we also have fridges and freezers to store your sample when you send them to us. And this is our pharma laboratory. Again, lots of space to build up something. And very important, we have this safety workbench, which allows us to handle also some pharmaceuticals which are toxic or toxic ingredients, like for example, battery slurry extrusion. And so before you come here for trying tests with your samples, we were happy if you send us the MSDS for your samples, and then we can evaluate if we can handle them here in our lab.
So I think at this moment, the picture from Annika stopped on my side. Nejla, are we still on?
Back again. I got
Yeah.
kicked out.
Thank you.
Sorry, I kind of got kicked out.
Yes.
Yeah, what I wanted to say is, yeah, you can either come here together with your sample to our lab and we find the solution together for your specific problem. And another possibility is also, we're really trained in it now, to send us some samples and we do it online. So we are equipped with a lot of cameras, and then you have 2 people in the lab dealing with your sample and recording a video. You get a video afterwards, and you also get a report, and you can also connect via Teams to this trial day and watch us working with your sample. The good thing about our customer centers, if it's not about farm application, the first day of trial is also for free. For further days of trial, we have to charge, but you get the refund for that cost if you order then the equipment within 1 year. And with this, I'd like to hand over then back to Ansgar.
Thank you, Annika. Yeah, I always see this or find this very amazing, how this development has taken place over 1 year, 1.5 years now with the stupid COVID. How you turned into actors, how you carry the camera around, how you have the cameras during the videos. This day I saw the sample testing on a rubber profiles for a customer, and also that video, for example, is very amazing, very descriptive on the process. And yeah, almost, I don't know if it's really better than being in person there, but it's very close to that. So,
both has advantages. We do our best. In any case, we do our best.
Okay, I will try to switch over to the presentation again, and hopefully this can work over here. So, Nejla, is the presentation there? I hope so.
Yeah.
Yeah, perfect. So what is the next step? You've seen the 3D printer. Actually, the 3D printing process is more or less new technique, which gets more and more popular. And we will not really talk on the standard version of this process. So, you know, this process works is one part of the 3D printing can be the fused deposition method, which means a strand of a polymer is pushed into a small die of the so-called 3D printer. But to make this strand, that is in a large scale quite easy. And what is commercially available is a growing number of different compounds of different polymers for various applications. Even biodegradable materials are available now. But if you would like to create your own ink, so to make your own filament, that is quite tricky. So we recall the introduction, a single screw, which is a normal way of processing such things as a small noodle, the small filament, cannot mix. So to make a polymer compound, we would look on a twin screw extruder. So having a twin screw extruder, because single screw extruders are limited in mixing, we would use a combined process. So let's go on here. From the various sizes of the systems, we can now select for the twin screw compounder, and we will mainly look on something which gives us up to 2 kilograms per hour. What I liked already in Annika's presentation was showing the different sizes of the instruments and the way how you can configure the screws. So you see here the normal conveying elements, which are the most common ones. Actually, there are quite a lot of conveying elements, but there are also mixing elements or other elements specifically for distributive mixing challenges. Going over, the conveying elements come in different pitches. That means how many turns they make per 1 L/D, and also in various depths. So when we look further, there is one important term we always like to highlight. For small-scale extruders, it is always a balance between what is the highest volume we can feed our material versus a high torque. High volume is good for small-scale processes, is good for bulky powders, is good for something like recycling materials, materials which come in irregular shape. So we need volume to feed those elements, the materials. And you know what goes into the extruder can come out. What doesn't will not come out, and the whole process will not really work. So it's a balance, what we consider as the highest volume and saving on some metal. You see the hexagonal screw shaft over here. Yeah? If we would make a small volume design, a high torque design, we would have here a very big piece of metal actually. Yeah? And so this gives us a higher torque compared to a smaller screw shaft. So we always have to find a balance, high torque, high volume. High torque for industry is good if it comes to maximum output to run a process 24 hours, that is clear. But usually those extruders are kind of much bigger and will not look on feeding problems. Well, when we have shown the smallest extruder, twin screw extruder size from the parallel twin screw is about 11 millimeter screws. So this is very tiny, and we designed the system in a way that we also can feed pellets. Yeah? And that is the main importance for the process 11. Looking over to the next part is the screw element. Mixing elements can be arranged in various ways. So in a forwarding zone, in a neutral mixing zone, which will have higher mixing powers. Usually in those zones, we achieve the highest energy input. So the material temperature will increase. The pressure will be, so the mixing zone always will be full. There will be always pressure inside this mixing zone. And we can create a different offset to increase the mixing power. Yeah? Even selecting them not from forward direction, but in a reverse direction, which will help us achieving higher residence times. So showing two examples from a screw design, higher shear, lower shear by changing offset of the elements. The nice part is we can choose those elements one by one, disc by star by the star by disc again. So these are called distributive flow elements, distributing small quantities of additives into the metal. And by arranging those screws, you see a typical screw configuration. When we start looking at the screw configuration in the first open port, we have the so-called feeding port. Usually it is cooled. The material will drop in. The extruder barrel usually is a hot process, so it's cool to prevent the material melting in the feed section and to block the feed section. Once the material gets into the screws, it gets transported, heats up, and when it arrives into the mixing zone, the pellets are crushed, molten, and pushed over to the next conveying zone. Here is another opening. Typically, we would add here a second component to make a compound, be it a colorant, an anorganic filler, but it could be something like a wood composite, or in terms of pharmaceuticals, it might be some API, some plasticizers. So never mind, it's a big opening for, let's say, powders or granules. It could be closed and could be with a small tube to inject liquids, for example. Also, this secondary component needs to be mixed inside, so there are various mixing zones. Another transport zone, mixing again, an open transport zone, for example, for degassing. And what I forgot is to switch you the different steps, which I will do now. So you see up to 3 compounding zones, 1 zone for venting, and here are always special elements which have less volume to compact the material, to increase pressure, that we can go over to the next step of the process, which usually will be a strand production, a sheet production, a blown film production. or convey it to another instrument like a small injection machine, or to convey it to a melt pump, for example, right? So we call this the extrusion elements. So this is a barrel configuration, screw and barrel configuration. Both is modular, both can be changed by our extruders. Even we could change the extruder length, so the working length of the extrusion process. So with going back to what Annika has presented to us, what I really liked was to show how easy it is to put a screw element on this hexagonal shaft. And you can imagine now you can build your own screw. Of course, we have expertise in our application lab. We can build the screw for you, but what is even better, you can try out the screw by yourself. So you can design the screw. It's easy to change over the screw elements. The application team sometimes during a test day is changing the screw configuration 1, 2, 3 times, yeah, just to find out the most efficient configuration for the process. With that, I would like to switch for a video of the newest system we do have. It's a compounding example. Yeah. Let me see if the video would work. Sorry, not yet. I'm trying to go with the video. Let us see. Hopefully. So do we see our video of the newest compounding system we have? Nejla is nodding, that is nice. So that is one step bigger, 60mm screw, and the compounding task is, let's say, creating a filament basically made from polymer together with a wood compound. So we are going to feed the material, and here we can now see the top feeding. First, we feed the polymer. The polymer, you see how easy the pellets go into the extruder. They get pushed forward. And in the second step, from the top feeding, we add wood fibers. So wood fibers is especially difficult because you can see they're very lightweight and they have a very bulky, sticky kind of feeding behavior. And what we will see, if we go too high in the feed rate, it will block the feeding zone. So here we get a little bit unstable feeding behavior at higher throughputs. So that is made in this new system as an example how important it could be for a side feeding. Of course, side feeding is always possible when there is enough space on the screws. And so it had been a quite new design for such a small extruder to use a twin screw side feeder to push the wood fibers into the extruder itself. So here you see the same or higher throughput of wood fibers, and below there are running 2 parallel screws only for the feeding purpose and push them into the extruder. So you see here the strand is collected, it's cooled in a water bath, and then either we could go for a 3D filament with a spooler, for example, but here it's a very standard process using a cutting system and create new pellets. Okay, so good. And following the presentation, I hope that is on now again. Looking to twin screw compounding, thank you, Nejla. We will see the different variables. Yeah? This is a very crude overview on a twin screw extruder. So we have a motor with the kilowatts in power. We can measure the torque either by torque sensor with a polylab system, for example, or by the motor power, calculating the Newton meters we apply to the screw shafts. We have the feeding in kilogram per hours, cooling. We have a screw speed, RPM. We are melting the material. We need to heat or cool the extruder barrel, eventually we will take out some gas, some vapors by a vacuum venting. We can measure the melt pressure, the melt temperature, and of course the output of the process. And so, summarizing over here, we can see the different variables, dependent variables and independent variables. So for example, in a continuous process, what we can change is the feed rate, the screw speed, and the temperatures. A step change means for us stopping the machine, changing something. Yeah? We could change the barrel design, we can change a die, or we can change the screw design. From these independent variables, we will now see a melt temperature is depending on the different variables we have set before. The melt temperature, temperature as well, the melt pressure, highly depending on the feed rate. Drive torque, of course, residence time is influenced by screw design. Yeah? And from there, we get parameters like how good is the dispersion, how good is the compounding, or how good is the color concentration or the color distribution inside the pigment distribution inside a master batch, for example. Okay, sorry. When we talk on melt temperature and what we can see, there is always a process boundary. We call it a feed rate and screw speed diagram where we can see this process boundary. Either it is determined by the volume, so that means you cannot bring enough material, somewhere is a limit to push material into this extrusion system because it's smaller lab scale. Or the boundary might be torque for difficult materials with high strength, high tensile materials which are difficult to melt, for example. And we see with increasing screw speed, we have here isothermal lines. So with higher screw speed, the temperature will increase also. When we go over and see a nice diagram how we will develop a twin screw process with these extruders, there is one mistake many customers actually do because they're used to single screw extruders. Yeah? A single screw extruder is operated in a way that when you increase the screw speed, the output will increase. So the single screw extruder will take normally all the material it can get from the hopper. In this case now, for a twin screw, it is different. A twin screw always is using controlled feeding. Yeah? So let's say as a recommendation, we would start at not minimum speed rate, something below 10 or something. That doesn't make actually sense because the screw are turning very slow, the residence time is very high. And so let's start at something like a 50-100 RPM. So we start at point A, low screw speed, but not lowest, and a low throughput. We check what is the torque, and we can increase the screw speed, and then we can start to increase the throughput. So we change for the feeder, the set points, and give more material to the system. We see the torque will increasing, and then we can speed up again. And after that, increase feed rate, speed up again, increase feed rate. And once we stay with our points below the process boundary, we will have a stable process. And in this way, you can select different speed and throughput combinations which are useful for your material. Going over again, we talked on the residence time. We can change residence time by screw speed, but what is more important is the throughput. Again, very small screw throughput at slow speed rate is creating a very broad residence time. Yeah? So in this way, we should avoid and design a process that we are using intermediate speeds as well, residence time, to be comparable in terms of scale up, to be comparable to further industrial processes. So let's now have a short look, and I think our time, I'm speaking a little bit too long, for the production of the 3D filaments with a twin screw extruder. The challenge is when we compare to a single screw extruder, the pressure behavior in a twin screw extruder is a little bit inhomogeneous. It's fluctuating. in the process. So that is the nature of the twin screw extrusion process. On the other hand, the mixing is excellent. So how to overcome it and go to a step which is similar to single screw extruder to create those filaments for a 3D printer. So in this process, we now introduce a very small scale melt pump. The melt pump is attached to the extruder. A melt pump, a so-called gear pump also, is a heated component with 2 gears. They are taking the melt and process the melt through those gears. So they compress the melt, they boost the pressure, and by the number of many tubes in those gears, they make a more equal pressure behavior. So they equalize the pressure coming from here, from the extrusion, from the twin screw extruder, and create an even pressure profile at the die tip over here. And all this line can be a small tabletop line, as in this case. Yeah? We see again, like in the previous video, main feed, secondary feed on the twin screw extruder. What is new is a melt pump. And with the melt pump also, we will have, sorry, I should use a pointer over here. So main feed, secondary feed, the twin screw extrusion system, a melt pump, and running either through a water bath, or in this case, just on the air, the cooling, through a laser gauge for checking the diameter, and a small spooling system to wind up this coil for the 3D printing. Okay. Trying for this video. I think it's running, showing the extrusion line over here, small filament line. And the interesting part is also mentioned from Annika through the lab tour. It is quite easy, be it for pharma or for battery application or wherever we have kind of hazardous materials, to put this system into a glove box. It's a very small footprint. Here you see nicely the temperature profile on the extruder. We start at lower temperatures for the feeding and increase the temperature over here. The melt temperature actually will result by the compounding and the introduction of energy to the system. Going further down through the melt pump, an even strand is taken off. It runs into a water bath. We can change actually the nozzle diameter to fit the strand diameter. It's important to know the diameter of the die nozzle is not necessarily exactly the final diameter, because we have die swell, or we are thinning the melt because we are pulling the strand, and when it solidifies there might be a change in volume. So finally we have to set here or we check here the diameter and have to adjust the extruder in a way that we get the desired diameter. And so here you see winding up the small strand. We compared actually the results is twin screw extruder and twin screw extruder green line with a single screw extruder with the orange line, twin screw extruder with a melt pump, and it's in the same range. So we can say here we have challenged, solved. We can create those strands by using a gear pump, and for you important, we can now design your own material. Yeah? If there is a compound not available in a catalog as a ready strand, we can design it. We can make those types of compounds and go to a further process. So a minimized lead time, it means if you have different ideas, you want to test many materials, you don't need to check if they are available and wait. Yeah, you can just create them by your own. There is only small waste created. Yeah, we have small lab space. We have a production scale. Actually, it's an extrusion process. So if you need more, you just leave the extruder running for a while. Of course, it has its limitations. Yeah, if you try to make a 50 kilograms, you see, okay, it will take a day. Yeah, but it's possible. Quick product changes. processing parameters can be recorded. You can cool and collect the filaments. And what is important, it is scalable to production, because also in production, you have twin screw compounders of a similar design, of similar lengths. And so also you can use scale-up methods to create a process for these newly found filaments. Now we have seen a lot on the twin screw compounders, and I want to draw your attention to this picture. Also here, polylab system with twin screw compounder and a melt pump. And instead of using a spooler, we are using the melt pump to make extruder type rheology. And with this, for the rheology part, I like to hand over to Nejla.
Thank you, Ansgar. Yeah, actually, I'm going to talk about the rheological measurements with compounders and reometers. Yeah, actually, Anika showed us a small scale machine, a mini lab, but I just want to have a small video which will help to understand the application. I think you see the video right now. Yeah. Okay, so let's start, which is showing actually the workflow, which is very easy for compounding and then having the test specimens with our lab type machine injection molder. This is our mini lab, which is standing on the bench, you see, at a very small scale. And either you can use co-rotating or counter-rotating screws. And you see co-rotating screws right now. Depending on the application, you can also choose counter-rotating screw option. As we said before, these are conical twin screw. Easily you can mount the screws, extruder, as shown by Bernd. And just I want to talk about the inside. There's a backflow channel with the pressure sensors, 2 pressure sensors. I will discuss later the importance of this. This is automatic bypass valve, which is circulating material inside, going to these 2 pressure sensors, and it's automatically controlled by the software. Easy to close the extruder, just 6 screws. And then we can program it from the tablet. Very modern design, setting up the conditions. The temperature and screw speed. And then we go. Yeah. After compounding, we will go directly to injection. So that's why we are attaching the mini jet adapter to mini lab. Okay. And then we are going to feed our material with the pneumatic feeding device. Yeah, we are feeding our pellets. And here we go. Yeah, Now, after compounding, we will go to injection molding machine directly with the adapter. That's why we need to program our program for different polymers. We have the table for different polymers, the injection pressure, and the temperature, of course. So it's preheated. The cylinder of the mini jet is preheated. And whenever we complete the compounding, just mounting the heated cylinder of mini jet to mini lab and opening the bypass valve, we will have material in our cylinder. Yeah, here you see it's transferred to the cylinder, preheated cylinder. And now ready to have our test specimens. Just closing the door. And 1, 2, 3. That's all. We will have it in the mold. And we can have different molds for different test specimens like tensile or reometre discs or DMA bars. As Annika already showed us one mold in the lab. Yeah, this is very easy. Okay. This video is can be very easy to find in the YouTube. And now I will go back to my presentation. Today, I have chosen 2 application modes actually. I know we are running out of time, but I just want to discuss about the possibilities of the rheological measurements in compounders directly. And of course, after compounding, as we seen in the video, it's easy to have the plates, discs for oscillatory measurements. So these both 2 applications are talking about, discussing about these possibilities and how to correlate this data. So as we already introduced you, the mini-lab is small-scale twin-screw compounder. We can have compound our material, and in the instrument we have 2 pressure sensors, which makes us take data for rheological measurements. And thanks to our software, Polysoft OS software, we can have the viscosity graphs. So here you see PET with no additives and with 2 different additives. So we can see the reaction inside, the decomposition reaction of PET, and how pressure...
Necla, sorry, we cannot see the presentation.
Really? I'm sorry. Mm-hmm. Let's try again. What about?
Now, okay.
Okay, thank you. Okay, I think something is related to the connection, internet connection. So we can test directly in the mini compounder the PET with no additives and with the 2 different additives and see the pressure graphs, how pressure differs during the processing. And we can also have these oscillation data afterwards, as we see in the video. We can prepare discs for parallel plates, which is in this application of 20 millimeters parallel plates, and the data is taken from HAAKE Mars 60 advanced reometer system. So here you see PET with no additives. This first part is related to the fitting, and then you see that the pressure drops and viscosity drops, and it ends like 18 bars. So we see also the oscillation data with the loss and G prime and G double prime. And whenever we go with 1% of additive, which is 1, 2, 4 benzoyl hydride, we see that again after the feeding zone, we see the increase in the pressure, which is related to the reaction, of course, decomposition reaction and shaping with different structure. And it ends at 15 bars. And again, we see the oscillation frequency sweep data. So we see that actually the structure is changing and the viscoelasticity is also changing. And in the third trial, you see PET with 2 different additives again. And here we see completely different structure. The pressure is increasing up to 55 bars, which is also related to the structure forming. And we can also have the data from the oscillation data, which is correlating with these results. So as a conclusion, we can say that it's possible to have the rheological measurements directly in the compounder during the processing. But of course, if you go for further testing or broaden the range, we of course need an advanced reometer system. And in the second application note, which can be also found in the thermofisher.com site and many other application notes, we again have the rheological measurements with the HAAKE Minilab 3 microcompounder. And we have, again, dynamic oscillation data with the HAAKE Mars 60. So in this case, we have 5 different samples with low density polyethylene grades. Different samples are mixed. So we take again the measurements during the compounding, and you see that 2 measurements, so measurements we take from slits, what we call slits capillary, are relative measurements, but whenever we compare it with the absolute measurements which are taken from the reometers, they are matching, they are identical and correlating to each other. But as I said, if you go to, if you want to broaden the range, we still have reometers for dynamic oscillation data. That's why I just want to discuss a little bit on our product portfolio for reometers. And in 3 steps, we can go for our reometer range, which is in the first step, very compact reometer, which is called HAAKE Viscotester IQ, for control, for quality control, or even for R&D, very basic type Viscotester IQ model. And then we have a versatile reometer, which is called HAAKE Mars IQ reometer. And for really R&D and development, we use HAAKE Mars 40 or 60 instruments. So if we just look at the Viscotester IQ Air, which is air bearing system, we can do the whole rotational measurements and oscillatory measurements in this reometer. We have 2 versions, air or mechanical bearing versions. Of course, it's easy to get data directly from the screen on the instrument, But it's also possible to transfer data from the PC with the Reo app application, or can be still used with the PC control with the Rheowin software. For the Mars IQ, we have, of course, Mars actually stands for Modular Advanced Reometre System, and we see here really modularity of the system. And we have different options, and the dimensions are very flexible to have the different application needs. So we can have different temperature control modules, or for different applications, different measuring geometries. And on the instrument, we have a big touch screen, which is really helpful during the measurements. You can directly control from the touch screen. So we have different temperature modules, like from very low temperature, like -60 degrees, we can go up to 400 degrees with the electrical plate temperature module, especially for polymers could be useful. And we have the options for sample hoods, like if you need to have the inert environment, we can still have nitrogen flashing during the test. And we have, of course, different solutions for different applications, like polymers, food, petrochemical, or paints and coatings. Regarding the 40 and 60 reometers, I would say the concept is the same, the modularity, but a little bit broadened. I mean, here the temperature range is really very high, and you see we have 5 factors for Mars, which are future orientation. I mean, in the last part, I'm going to talk about the combined methods, the accuracy and ease of use, modularity, and of course, application-based solutions. So here is our H-frame design Mars. And you see, especially this is a nice feature for the low inertia in the market we have in the Mars. And the Rheowin software which we use to get data and to evaluate data with the graphs. It's very easy. And here we really go up to -150 degrees, up to 600 degrees with the control test chamber. And we have very different measuring geometries depending on the application. So yeah, I just informed you on different temperature control modules. And of course, the same applies for Mars 4060. Here you see control test chamber, which is very easy to use, and either can be used with the solid clamps for dynamic mechanical analysis testing. And you see this platform can be combined with different methods like dynamic mechanical analysis or FTIR or Raman, even with curing for tribology. So it's really open platform for the future. And here you see different combination methods like optical microscope, which can be used for crystallizing and melting behavior, and FTIR combination, which is called Rheology, investigation of polymerization processes and forming new structures. You can also see this formation of network structures from FTIR. And with the Raman combination, this is really a complete overview for the rheology. Yeah, we can use either for food, polymer, paints, inks, pharmaceutical, and petrochemical industries. So this is all that I want to talk about the rheological measurements, either with the reometers or with the compounders. So I think now it's time that we can go for Q&A section. Let's see.
Thank you, Nejla. Nice overview, nice presentation. So yes, we are here. I see also Annika is there. So if you have any questions, let's go ahead.
Yeah, you can just type in the Q&A or chat box directly to the speaker or general questions. Let's wait for a few minutes.
Somebody has to be the first.
Yeah. Yeah, we have at least thank you messages. Thank you, Professor Ünal. Thank you for your participation. I think we have. Thank you. Yasemin İlhan.
So I got here a question from Jasmine.
Yeah.
And the comment is on this 3D filaments. So whether they can be used in twin screw or in single screw. Actually, I would say most of the filament production would be with a single screw because it is pretty easy. But actually, this is, let's say, the first start of the process. And when we looked on commercially available filaments, it is a growing market. It had been many different kinds developed and produced. But what comes is, for example, somebody needs to make money. And so when you buy a coil of filament, if it's a basic polymer and just by changing the color and keeping the diameter, it can be already quite costly and typically also maybe not available in all colors you want in all polymer grades you have in mind. So even despite of a growing market, what makes it difficult is if you are in research, have your own component, an own API even for pharmaceuticals to create a suitable filament. And so we need to combine mixing and combining it to process material on your own. Yeah? There was a question on PEEK, I saw.
Yeah.
Yeah, okay. And again, a question on single screw extruders. I don't know because these single screw extruders we use for rheology, ours is a capacity of about 5 kilograms, I would say. But commercial available single screw extruders are available in all different kinds of capacities. Okay. Maybe keeping from the chat box this discussion on capacity of screw extruders, we are also in a, yeah, let's say a narrow range for our spooling. So this will be also around a kilogram per hour, 2 kilograms per hour. So go over, okay. A nice comment on the RS600.
Right.
3-4 years, yes. That is really good to hear.
But it's time to switch to Mars, maybe.
Yes, sometimes we have to say our systems last very long also for
Very long, yeah, right.
we have systems on the market for mixer especially, which are close to 30 years, and theoretically we could put them over to the new base units. So long lasting, whether it makes sense, it's a different story. Usually after 15 years or so, you might be allowed to invest in a new budget. Okay. Good.
Okay.
Okay. Okay. That was regarding the PEEK.
Yeah, this is our user of Process 11
Yes.
from Eskişehir Technical University.
So when we look on, so we have those videos also on the video portal. We can have a look. The challenge definitely is high temperature, and PEK being also quite a stiff material when it solidifies. Two challenges in one. Important thing is the process 11, if you would use it. So as probably the vast majority of our systems, it's not when we discuss on a solution with you, when we discuss on a configuration, it's not just one part number. It's usually a set of 10, 20 different part numbers to really to your needs. And in this way, I would also check if you have a process 11, do you have the high temperature version? Because that might be really a challenge if the high temperature option is not there. It is with a limited temperature range. With the high temperature option, if we know peak has to be processed, usually we do have a high temperature option. And then you can also use the system for different high temperature applications. The other question probably is more up to you, Nejla, Orkun, Melek. Yes, we do have extruders in Turkey. We have a couple of systems, not everything in one position. We have no demo lab, but definitely we have customers for our extruders, and not sure if you can arrange for people to be interested to have a visit if there is a university. Usually it should be.
Yeah. In the past, we organized many times in different universities like Hacettepe, in Anadolu University. Now it's Eskişehir Technical University, in Gazi University. So I hope in the future, whenever we go back to normal, of course, we can have a real demonstration in the lab, which would be easier for us.
Okay. All right.
Yeah, we're almost in the end. So thank you, everybody.
Yes,
It
thank you.
was so nice.
I see the number of participants nearly stayed stable, and now people start to leave. But thank you for your patience with us. Thank you for listening. And thank you, Anamet, for wonderful hosting of the webinar and all the nice reminders.
Thank you very much.
Yeah, thanks for the organization.
Thank you, Annika. It was really nice.
You're welcome.
Okay. No more questions, so I would like to close and
okay.
see you.
Bye-bye.
And bye-bye.
don't hesitate to drop us an email or post
Sure.
questions over to Anamit once they arise.
Yeah, thank you everyone for the participation. It was a great on. And I would like to thank all the presenters, also all the attendees who have joined us. And we will let you know if you on our social media, also email links in our future webinars, and we'd love to see you there as well. And yeah, thank you everybody. So we will be ending the session now.
Thank you.
Okay,
Bye bye.
Bye-bye.
Bye.